to the session on digital innovation and economic outcomes. I'm Ayesha Ali. I'm an assistant professor in the CNM Department of Economics. I do research in applied development, and a significant part of my research does focus on the use and the effects of digital technologies in the developing world. Let me also introduce my fellow colleagues here who are going to be presenting their work. We have with us Faizaan Kisat from the IMF. Faizaan does research on corporate finance, macroeconomics, and development economics. And we also have with us Sher Asad, who's a fellow colleague in the Department of Economics at LUMS and also visiting professor at Iowa State University. So without further ado, I'll pass it on to Faizaan, who's presenting first.
All right. Thanks, everyone. Thanks for being here. As Ayesha introduced, I'm Sher Asad. I'm an assistant professor here at LUMS, and I'm also visiting assistant professor at Iowa State University. So I am pretty jet lagged. So just a disclaimer: if anything doesn't sound stupid, it's definitely because I got here in the morning and haven't slept since. But with that, let's get right into this. So this project is about evaluating a program which is being rolled out in Iowa, in Khyber Pakhtunkhwa. And the motivation comes from the fact that in developing countries like ours, there is this information problem between tax authority and taxpayers. So basic problem in this public finance or in the tax compliance literature is that taxpayers know more about their sales or about their income, and tax authorities typically lack that information. So they don't know what true level of sales are or what true level of income is. So this intervention that we are evaluating here, this is aimed at improving that information exchange between the taxpayer and the tax authority. So what it does is it's a electronic point of sale devices. They are basically installed in business locations, and whenever a transaction happens or whenever a business makes a sale to any customer, that transaction, if it is conducted through these devices, this is reported in real time to the tax authority, and then the tax authority can verify what were the actual sales, what was the true level of sales by the business, and then they can reconcile that with the reported sales that the taxpayers are reporting or self-reporting to the tax authority. This intervention, the point of sale devices, are supposed to solve two problems. So they can provide better information for tax collector, as I explained, because they now have information on what were the actual sales. And it can also improve record keeping for the taxpayers, because now if everything is done on this electronic system, they have a clean record of what the sales were. So it is likely to reduce their compliance cost in terms of filing all the paperwork and preparing their tax records. Right. So in the interest of time, I'm not going to dive a lot into the literature, but I would say that there is very active research on using third-party information and how it can improve tax compliance. So we contribute to that literature. There is also quite a rich literature on how increasing the threat of audit or the perception of getting caught, how that is going to improve tax compliance on part of the taxpayers. More closely, there's very active research on evaluating exactly these kind of programs. For example, in countries like Rwanda, Peru, Uganda. So there's a lot of active area or active research in how these devices or how these kind of interventions overall improve compliance. So we contribute to that literature. And finally, at a broader level, this is where this fits with this session also. This is about evaluating how digital technologies can improve tax compliance. All right, so let me get a bit more specific. So this intervention or this project is about evaluating, it's this initiative by KPRA. They started in early 2021, where KPRA started encouraging businesses to link their already owned devices. So this is not a new device that is given to them. This is like businesses, they already had their point of sale devices, but they were not linked with KPRA, which means that all the sales that were conducted on those devices, they were not reported in real time to the tax authority. But once they are linked, linking basically means then they have to install a certain software, right? So once that software is installed, then the information is transmitted in real time to KPRA. And businesses also gained an access to a dashboard which could tell how many transactions were actually reported. So this is where this is likely to reduce their compliance costs, because now they have a portal where they can see all the transactions. They can just download it, the list, and submit it with their tax records. So that's likely to reduce their compliance cost. And there's a subset of devices which were given to businesses. So this is linking plus giving them a new device. So some businesses that KPRA identified, which were given the whole device itself, just to increase the penetration of these devices. This is sort of describing the rollout, how, as I said, this started in early 2021. And you can see that until about 2023, May 2023, KPRA has rolled about 250 or 240 devices. That's what the total distribution is. And this paper is about evaluating those devices and what impact these devices had on business compliance. Uh, there is a transition happening in KP right now as we speak. They have this approved in the Finance Act that from the next fiscal year, every business in the hospitality sector, restaurants, tourism, and these kind of companies, they are required to have these devices from the next year, right? So this is evaluating this voluntary compliance. These businesses were not required to have these devices, but they were incentivized to adopt them. I'll talk about what those incentives were. But this is looking only at, okay, once they have adopted the device, what had happened to their sales, right? And this can tell us something about what might happen as we scale up the rollout. All right, out of those 240 businesses that were linked, eventually we had some issues with the data. So the final sample is working with 179 businesses that were linked between December 2020 and May 23. As I mentioned, most of this penetration is in the hospitality sector, which is restaurants, some tourist company, hotels. So that's the bunch of businesses that we're talking about. There were some beauty parlors that were also linked, but most of my discussion is sort of focused on hospitality sector. Just to give you context of what kind of businesses we are talking about. On average, the businesses that were filing, so this is a context where they have to file monthly returns. Every month they have to report their sales to KPRA. So all these businesses that are registered, they file months only 3/4 of the time. So it's not that they file returns every month. So this is a low compliance setting. This is just like whether they are reporting anything to the government or not. So only in 75% of months there is actual tax filing happening. More than half of the filed returns are actually null returns, which means that they say that there was no sales or no business transaction. So they just submit a form and say that, okay, I did not have any sales this month. And in a typical month, a filing business paid about 23,000 rupees in taxes, right? So these are small businesses generally, and that's what they're paying, right? Mazhar is giving a keynote session in this conference. He's going to talk a lot about these null returns. Like this is a huge problem in Pakistan. So we'll get to hear more about this. Right. So I mentioned these are not mandatory devices. These businesses were incentivized to adopt them, and the incentives were that if a particular business decide to use this device, they will have to pay 6%, or they can choose to pay 6% tax rather than the 13% tax, which is standard in NKP. Right. So this was an incentive, and this 6% tax does come with a caveat that if they decide to go for 6%, these businesses cannot adjust their inputs. And what that means is that these are value-added tax, which means a value-added system, the way it works is that you buy inputs, you add some value, and you are supposed to pay taxes on the value added, what you have added on your input. So for example, your inputs were rupees 100 and you sold the thing for 150. So 50 is your value added, and that's what you need to pay taxes on. But if you decide to go for 6% tax, that means that you cannot adjust that rupees 100 into the taxes, right? So you have to pay 6% on all 150, right? That's the rule. This is how most tax authorities do it. Even in Punjab, this is how they are. Whenever they offer a reduced rate, they take away this provision. And the argument that is typically given is because these businesses are not buying from the formal sector, everything that they're doing is from the informal sector, so they cannot really claim any input tax adjustment, so it's okay to just uh, do it on the sales basis. So in a way, the value-added tax becomes a sales tax here, right? So it's not really a value-added tax then. But this is what it is, and this is what we are evaluating, how this is impacting the firm's sales. In terms of the rollout, this is how we are defining the rollout. So 0 is the time when a particular business gets the device. So if an invoice is issued using a device in a particular month, we say that the device is still being used. So of course, when the device is given, the take-up is 100%. But right in the next month, you see that the usage drops to about 70%. That means about 30% of the businesses stop using the device altogether. They're not using it, even though they get the device, but they stop using it. And this is very generously defined take up, that we are saying that they issued at least one receipt in a month, right? And over time, you see that the compliance sort of, or the take up sort of remains at about 65%. That's where the usage is for our businesses. This is an interesting figure, although it's not going to be a focus of this study. But we did look at the sales that are reported on these devices versus what these businesses are reporting to KPRA, right? And it turns out, if you try to tally the two, what should happen is that the reported sales on the devices must always be less than the reported sales that the taxpayers are reporting themselves, right? So if you're doing all your sales on the devices, then they should match 100%. But if you are using devices for some sales, then your actual sales should be greater than what is done on the devices. But surprisingly, what we see is that the sales on the devices are about double it, actually 2.28 times more than what is reported on the tax returns, right? So this is an issue which highlights the lack of enforcement at KPRA, that even though this information is right there with them, that okay, we can see these sales happening on these devices, and these businesses are not reporting them, although there's clear evidence of these things happening, but they're not really doing anything on it, right? So that's just give you a context of this is a very low compliance setting. Even when you give the devices, it's not guaranteed that this is going to lead to actual reported sales. In the interest of time, I'm going to skip over some of the technical details, but essentially we are thinking that this device, once it is given, it has two impacts. Either it's going to reduce the compliance cost because it's easier for firms to file their returns now, or once you get a device, it's going to increase the threat of audit, that now the tax authority knows my sales, and they're probably going to come and ask questions, right? And that might encourage you to report more sales or report more accurately, right? So we think that these two effects can, in our basic model that we adopt from this literature on tax compliance, that there could be a permanent increase in reported sales because it's now easy to report taxes. But then there could be a transient effect if you might think that there is a increased probability of getting caught, but when you see that nothing is happening, that threat or that perception might come back to your baseline levels, and now you might start to think that okay, even if I'm doing sales on this platform, nothing is going to happen, and then you go back to your behavior, right? So to really test that what is really happening, is it the permanent increase or the transient effect, we look at this event study specification, which is sort of a difference in difference comparison. The basic idea is to compare businesses that got the device with those businesses that were very similar looking to these businesses, but they did not have the device. And we try to see that after they get the device, over time, how does the sales of the businesses that got the device compares with the sales of people that did not have the device, right? So that's sort of what we try to do. And this is going to be a common result here, but the first thing we look at is, do firms start to report more sales? So what is going to be an impact on reported sales? And what you see here is that this 0 line is, or this -1 line is 1 month before getting the device, right? So this is what we are comparing to. So 1 month before getting the device, businesses that got the device were very similar to the ones that did not get the device, the ones that we're comparing them with. And then we see that after getting the device, in the first 3 months, the reported sales sort of significantly jumps up, right? In fact, it's about double, like they double as compared to the ones that did not have the device. But after that, we see that there is sort of tapering off that effect, that this effect sort of goes away. So there is this initial increase, but then it sort of dies down. In the context of the model, this implies that there's this story of that perception of getting caught. That is something that might be at play here, that you think that, okay, there is increased probability of getting caught, you become more cautious in reporting, but then over time you see nothing is happening. The tax authority is not doing anything on it. So your sales sort of drops back to the same level as before. In terms of reported purchases, we see similar pattern that you reported purchases are supposed to work in a opposite direction, that if you're reporting more purchases, that means you're saying that my tax liability should be smaller. I had so many inputs bought. But we see that actually your reported purchase decline, which means you are now more aware that if I have to verify these reported purchases, then the tax authority is going to ask me questions, or they're going to ask me to provide some documents of whether I actually bought these inputs or not. So it sort of lowers your reported sales. On the value added, if I take the difference between the reported sales versus purchases, overall you see that both effects sort of increase the value added into the production. So this is, again, similar story that you see that in the first few months, the compliance increase a lot, the reported value added increases a lot, and then it sort of dies down and come back to the same level as before. Amount tax paid, what they're actually paying, same story. Taxes go up, they start paying more, but then it sort of goes down. In the interest of time, I'm not showing you where this effect is coming from, whether it is the existing firm that were paying, they started to pay more, or is it coming from the fact that they have started to actually, firms that were not paying at all, they have started to pay more, right? Is it the question of extensive margin, or is it a question of intensive margin? It turns out it is the story is sort of both. It's coming from both sides. But on the tax side, so for sales and reported value added, it's both extensive and intensive margin are at play, are driving the effect. But on the amount paid, it's actually, can I quickly click on this and intensive margin, yeah, if it's gonna work. Okay, it's not gonna work. That's fine. The important point I want to make here is that because when these devices were given, there was this incentive scheme that if you use the device, the tax rate is going to be lower. So that is something that is going to cause the tax revenue to decline. But on the other hand, it might encourage businesses, because of that perceived threat of audit, it might encourage business to actually start reporting more, right? So that's why these incentives were given. And we find support and evidence of that, which I wanted to show you from intensive and extensive margin, that firms that were using the device and reporting positive amount, their compliance did not change much, right? It's not that the existing firms started to pay more. In fact, the tax revenue does decline from them because of the tax change rate in change in tax rate. But it is the firms that were not paying anything, that were reporting no sales, those are the ones that are starting to pay more, right? And that is causing a net effect in the overall tax rates, right? So that's pretty much it. I think I can. There's no effect on return filing. It's not that the return filings are increasing. And that's pretty much it, right? Just to summarize, this paper is looking at this impact of a very small rollout, but what we're finding are encouraging effects. But we do see that these effects are very short-lived. So in an environment like KPs, which is highly informal, very limited state capacity, very limited enforcement, these effects do not last, but at least they work in the direction that we intend. And there is some evidence that these incentives that are given to adopt these machines, they are working, even though they lead to lower tax collection from the businesses that are probably reporting true or near the truth, but businesses that were not reporting at all, they are the ones who start to report positive sales. Right? So yeah, so I'm going to stop here and look forward to the comments and discussion.
Okay, hello everyone. I'm Faizaan Kisat. I'm an economist at the IMF. So I'll be first discussing Sher slides and then I'll go on to my own presentation. I am obligated to tell you that the views expressed herein are those of the author and should not be attributed to the IMF, its executive board, or its management. So with that out of the way. So I'm just going to quickly summarize the paper. Four kind of big buckets the way I read the slides. Motivation, okay, you have tax collection that's plagued by information asymmetry. So then the research question is, okay, broadly speaking, what is the role of technology, in this case, the EPOS devices, in improving tax collection? And I think, just to give you some context, even though the views don't represent those of the MF, this is a question that is really important on the policy side, especially within my division, fiscal affairs. People are really interested to think about what are the permanent ways in which we can boost tax revenues permanently using digitalization. So the context is POS devices were linked to the Khyber Pakhtunkhwa Revenue Authority, and the two main results that I kind of took away were that there are significant but short-term positive effects on sales and taxes paid, but these effects dissipate after around 12 months. So I have two kind of sets of comments. I have the main comments, then I have kind of supplementary comments and ideas for further research. So I think some of these were already answered by your presentation, so thank you. So please ignore the ones that you've... So I think one thing that was interesting is this variation in the rollout of EPOS devices. There were periods where there were peaks and then there were periods when it went down. And so I think there's something going on here, and I was trying to figure out, aside from the propensity score matching, is there any way in which you can exploit this variation? What were the kind of underlying factors behind the variation, and does that give you some exogenous variation or plausibly exogenous variation? What fraction of transactions are covered by POS? So you showed us the graph with the transactions divided by the but that's almost like that's a numerical one by value. I just want to know the number of transactions as well, if there's data on that. And then, was the reduced tax rate passed on to consumers? So is it that the case that when, I guess, was there behavior on the, do you observe any prices? If you don't, then that's fine. I'm just interested to see whether that was passed on or not. On the empirical strategy, my comment was they are obviously very similar, and there's the diff and diff literature, as you probably know, has seen a big debate over the last 2 or 3 years. So I think it'll be interesting to see if you've considered alternative methods like a synthetic control versus propensity score matching. Moving on to the results, I think there is a way that you could exploit heterogeneity in the sample to disentangle the mechanism. So if I'm already a null filer or I'm a smaller firm, then improved record keeping, which would lead to a permanent increase in your revenues, would be a bigger incentive, right? So if in the model if there's some way in the data that you could find people, firms that have that could benefit more from improved record keeping. Firm size is a proxy for that, I would imagine. Location, because you have people, I saw in the summary stats, there are some in major cities, some in more remote locations. So presumably those firms in more remote locations would improve more from better record keeping. Is there some way you could disentangle the mechanisms through that? Is the sales effect a switch from cash or an improvement in overall revenue? I guess in a way you answered this because you show both total sales and EPOS sales. But is it that if I'm already paying cash, they're saying, no, put it on the EPOS device? Or is it that actually you're seeing an improvement in overall revenue? And I thought it would be interesting, especially in the context of the rollout coming province-wide, are there spillovers for nearby businesses or treated businesses in a more treated area? So if I'm in a city and there are more hospitality businesses close to me, am I more likely to benefit because there's some information sharing going on? And I think you have the data to figure that out because you have at least the locations. I don't know if you have the exact addresses of the businesses. Okay, quickly on other comments. I think I'll skip over the clarifying questions because those I've shared with you bilaterally. I think two future research ideas seems like what you're saying if I put on my policy hat, seems like an improvement in technology should be accompanied by higher monitoring. If you have both, then maybe you could experience these permanent gains. So with the expanded rollout coming, could this be studied? Say, just off the top of my head, say the assignment of audit officers is random, so you could use a judge fixed effect design to think about some auditors are better than others, and that's random, and then you could see whether the effect of auditing introduced as part of this mandatory rollout is really going to boost revenue. And then I actually had a more kind of interesting but hard to study research idea, which is tax compliance and informality. So could linking to a tax authority incentivize more cash transactions? So now I have to report, especially with the mandatory one coming, I know I have to report the EPOS transactions. I'll be taxed on that. Does it create more leakages to the informal sector? And I think that's something I think worth studying and something that's a lot of interest as well. So I think that's all on my side. Thanks.
So thank you, Faizaan. We'll open the floor for questions from the audience, and we'll take about 7 minutes. Please, we're already late. So if you have a question on the presentation, please feel free to raise your hand. There's a mic which can come around to you.
So I just have one question. So like what happens once you have the audit? So is there like, do firms get fined or not? And if they're fined, like what happens to the profits or like revenues on the firms that's not just on the FPR side, but like do firms that are audited and then they have to pay fines? Like what happens on that front?
Thank you, Sher. This was really interesting. Mine is more of a clarification question. So I'm wondering what the incentive was for KPRA for giving these machines when they don't intend to audit. So what was the, maybe this is part of context, but what is their thinking behind this? Is it just that this will reduce null filers, or that we just get automatic data, but then we don't check if they're actually using it? I mean, just if you could explain a bit.
Great. I'll try to respond to all of them. Faizaan, I think they were excellent comments, and I think there's a lot of work that comes out of your comments that we can work on. Thank you. Uh, I think I'll pick some of the topics there, or some of the points you highlighted. We did try. So right now the specification we are using is event study, and the more precisely Sun and Abraham specification, which sort of controls for treatment affects heterogeneity because they are not uniformly distributed across everyone. There are, of course, other methods using the similar sort of specification, which allows for a robustness check. So our plan is to sort of integrate all of those with this and just see if they survive, if the effects survive, different assumptions on those. I did try with synthetic control as a matching thing. The issue with synthetic control that sort of I'm still trying to work out is that we have a rollout which is spread out. So there is variation on timing, which you also pointed out. And synthetic control typically sort of there's not much literature on like when you have varying timing, how you're going to match businesses on that. I think I take your point about comparing the record keeping by different characteristics of firms and whether large firms, how they are impacted versus the small firm. That's a well taken point. And we do see that a lot of this targeting was actually selective, that the KPR is actively trying to target those businesses that are relatively more compliant. So big businesses, and they are concerned about increasing this compliance at a really small business level, which has low sales to begin with, because their concern is that that's where the backlash is going to be higher, and these businesses will have a hard time complying with these with these devices. But we do have some variation on firm sizes and their reported sales, and that's where we can see how the effects are varying. Most of our rollout is sort of in 3 cities: Peshawar, Mansehra, and Ahmedabad. These are the 3 cities. These are big cities of KP where this rollout has happened. But that again is because they are targeting businesses that are sort of doing well to begin with. Unfortunately, we don't have anything on the actual cash transactions. All we can see is that what is reported on the device and what they're reporting on the tax returns. We do have sort of itemized information on what was reported on device. So we can see if somebody bought a chicken kadai, so we know chicken kadai is there. But other than that, we don't have actual information on what was the extent of cash-based transactions there. And this is something we are trying to do in our work in Punjab, where we are doing mystery shopping surveys, where we are going out to businesses and seeing and trying to compare that how many times the receipt is actually issued, does it lead to translation into these devices and that. But in KPV, that's something which will be, I think, it will be even harder. Again, I think when we talk to businesses in KP, the spillover is a huge concern. And this is where they say that, okay, if I start using this device, because people are going to stop coming to me. So that's their argument, that if we use this device, we have to charge taxes, and people are already complaining about prices being too high. And there's so many other businesses which do not charge this tax, right? So they would rather go there. So if a business or if a customer comes and say that don't issue me a formal receipt, they just go with that. They're like, okay, we'd rather not lose customers than going for that tax. So that's why we see these effects are sort of difficult. And this is where I think once we move to the mandatory rollout, then this problem sort of goes away, right? Because then everyone has to use this device officially, legally. So the spillover concern would be reduced. There would still be, of course, variation in that not everyone is registered. So there's a formality margin which is varying a lot here. But yeah, this is a tough space. This is difficult, like how other businesses affect compliance of the businesses that are already trying to be compliant. But yeah, so we have work on Punjab that we can discuss later, what we are doing there. So there's that. In terms of what really happens when these discrepancies are found, there's actually nothing happening right now. The law says that, okay, if a particular transaction, so the law is defined at a transaction level, that if a transaction is found which is not reported to a tax authority and it is actually being conducted, there's a fine of 100,000 rupees per transaction, right? But in practice, nobody does anything because there's such a huge informality here that if you start actually implementing or enforcing this law, this will lead to so much penalties that no one would be able to pay. So right now it's like don't ask, don't tell kind of policy, and just everyone is just working under that. For to your point, the incentive of KPRA is that their goal is to sort of increase documentation. That's sort of the broader agenda for this. And the idea is that once we have brought enough people into this rollout and everyone is using this, then we can start using the stick approach and try to enforce whether actually they are reflecting into the tax returns or not. Because the concern is that if they start really enforcing on the compliance margin, then it is going to restrict adoption. So people are going to be like, okay, once we adopt the device, KPR is going to come after us, and let's not adopt the device. So that's something they're trying to prevent, and they're like, okay, let's not do anything right now. Let's increase the rollout and then see if we can target businesses on that. Anyways, thank you so much for your questions. They were great. Looking forward to next presentation.
Okay, great. Thank you so much. Faizaan, you're up next. Please go ahead.
Okay, great. Thanks again to everyone. So today, I'm happy to be presenting my work, Loan Officers, Algorithm and Credit Outcomes, Experimental Evidence from Pakistan. I will state again, these views therein are those of the author and should not be attributed to the IMF, its executive board, or its management. Okay, so big picture, as I'm sure a lot of people know, financial markets are undergoing a profound digital transformation. Think about all the ways in which financial services are provided and how digital technologies are transforming them. These trends are particularly prevalent in developing countries. So for example, China and India lead the world in fintech adoption rates. And in sub-Saharan Africa, 21% of adults have a mobile money account, which is the highest fraction of any region in the world. There are two novel aspects. There are many more, but I think there are interesting two novel aspects of digitized credit markets. The first one is the ability to use computational methods such as machine learning algorithms to evaluate financial transaction, which of course, if you're doing something with a pen and paper, you can't do. And then the second is the potential to anonymize applicants. So of course, as opposed to applying for a loan in person, if I apply for it digitally, on the back end, someone can anonymize those identities. So this paper studies how both of these features impact the efficiency and, quite as importantly, the equity of credit allocations. Specifically, I study how loan officers and machine learning algorithms differentially respond to revealed applicant demographics. So just taking a step back, suppose that demographics provide an independent signal of creditworthiness. So by that I mean because of structural reasons, if I am left-handed or if I wear glasses or whatever the case may be, I'm more likely to have certain outcomes. Then for humans, that may exacerbate stereotyping behavior, but then may also enable equity motives if I have an incentive to be more equitable towards a group that I perceive to be marginalized. And on the algorithm side, that may cause discrimination. And you might say, well, an algorithm is just a computer, how does it discriminate? Well, the algorithm will see that characteristic that it observes and sees the outcome is worse, and the algorithm will just load on that variable, right? The algorithm doesn't care about the underlying structural reasons why people with glasses or left-handed people may have worse outcomes in certain regard. So then how to discipline algorithms is an open question. Should algorithms be banned from observing certain information, or should they not? So to study this, I conducted an experiment in Pakistan with 30 loan officers from a microfinance bank and around 5,500 digitally submitted credit applications. The loans were assigned to the officers, and then I used an algorithm to make approval decisions for the same set of loans. And then the key feature of the experiment was that demographics of the borrowers were provided for a subset of loans to each agent. And just a quick preview of the results, I find that the algorithm reports 21% reduction in default, in loan default, versus the loan officers when both agents, where an agent is an algorithm or the loan officer, observe anonymized applicant information. The officers display an equity preference and actually approve more women once they observe gender. So once I see that someone's a woman, I approve more of those loans, but they don't sacrifice efficiency in doing so. Thirdly, revealing demographics reduces the officer's discrimination against women and raises algorithmic discrimination levels. So I have a definition of discrimination quantitatively that I'll come to later on in the presentation. And using that definition, this is the result that I find. And then if you're thinking about, okay, what's the trade-off between efficiency and equity? One way to think about it is that if you restrict the algorithm to respect the officer's preferences, which is long way of saying the algorithm has to approve the same fraction of women and minority group borrowers and majority group borrowers as the humans did when they saw those characteristics, that could be an optimal decision maker and solve this efficiency equity trade-off. Okay, let me quickly walk through the experiment design. So I worked with a digital credit provider that for confidentiality reasons I'm going to call eCredit. eCredit dispersed loans to a whole bunch of applicants, including loans that were for people that were not creditworthy. And this is a key feature of the experiment because when you observe any data that a machine is trained on, that could be selectively generated, right? Because some human has made a decision. But because eCredit wanted to get as much of a data set as possible for its machine learning algorithm, it just lent to a bunch of people and made a loss. And so I don't have what is common in machine learning literature, the selective labels problem, if anyone's familiar with that. Then I created the sample from a subset of these loans, and minority groups were oversampled, where minority groups are women and men from KP and Balochistan. And then in 2021, I did the experiment, and then here are the two treatment groups. And the reason there are three boxes within treatment group one is that it's for the same set of loans, right? So that's why it's kind of all within one treatment group. So there's a blind loan officer that viewed the loan terms, so saw the interest rate, saw the loan amount, and then the applicant responses to a questionnaire. The questions were like, how much money do you make, what education level do you have, and so on. But these are all self-reported. And then I have a blind algorithm, which is a random forest, that also viewed the exact same information, right? So another unique advantage of my experiment design is I can control exactly what the machine sees and what the humans saw, and they saw the exact same thing. And then you have an identified algorithm that views both the things that the blind algorithm does, but also views applicant demographics, which is specifically age, province, and gender. Okay. And then, randomly, the loans were also assigned to treatment group 2, where you have identified officers. In particular, the same officers came the next day, and then they additionally saw borrower demographics for a different subset of loans. Obviously, they can't see the same loan again, so that way you have a proper kind of treatment group. Okay. Oops. I think the battery is maybe dead. Yeah, maybe we'll have to. Yeah. Yeah, okay. So I'm not going to, in the interest of time, have time to show you all the summary statistics, but one of the things that you might be concerned about is, okay, do the loan officers just have a different prior because they work in a microfinance bank, these are digitally submitted loans, like are you really unfairly pitting them against a machine? And what I find, which is kind of pretty surprising to me, is that the officer estimate of the average default rate of the loans is pretty close to the true default risk of the loans, right? So the loans do default quite a lot because, again, remember, this was a situation where the company just lent to a whole bunch of people. But what's really interesting is that on average, officers predict risk accurately, which means that even if they work in a different context in microfinance versus this digital space, they're carefully evaluating the loans, and their overall predictions are not that far off. Next slide. Okay. The empirical strategy, when I'm comparing loan officers and the algorithm, and I want to highlight this because it's a bit unique compared to how you might think of other RCTs, is you test the effect of a loan being assigned to treatment group N versus, say, N prime, where the treatment group is I, the loan application is N, and then the E is the demographic subgroup. The important part is it's for the same loan. That's kind of what I wanted to highlight. So for the same loan, I ask the humans to evaluate it, and then the machine evaluates the exact same loan. So any differences cannot be attributed to the fact that there's some unobserved component of the loan. This is the exact same loan, and so this is all identified of within loan variation. Okay, and then when I'm comparing, which I didn't have time to show, when I'm showing the loan officer results, of course, those are different loans, but I have loan officer fixed effects. So again, you can't attribute any of these results to the fact that a loan officer might inherently be more equitable or inherently be more experienced, things like that, right? Okay, result number one. Let's compare the human that can see demographics versus the human that cannot see demographics. What happens in that situation? Yeah. Oh, is it working? Ah, okay, good. Ah, okay. So here on the left panel, this is loan approval, which is just a 1 or a 0 if you approve the loan, and then on the right-hand side is the loan default. So what I show is overall, when loan officers can see applicant demographics, they approve more people, but then the most of this is on women. So around loan officers are around 10 percentage points more likely to approve loans submitted by women once they can see gender, which is around a 22% increase in approval rate. And providing a stronger signal of identity, therefore, leads to better selection outcomes for minorities. More importantly, I think this is an important point, is that there's no trade-off with efficiency here. So the officers, in a way, select the right type of additional women, and men as overall default is similar. And these results are even stronger if I condition on approval. So this is for all the loans because you're doing intent to treat, but if you condition on loan approval, then the default rates are pretty much the same. Okay, now test 2. Let's have both the machine being blinded and the human being blinded, right? What happens in that situation? Oh, no, sorry, this is the other one. Now let's do the same test for the algorithm. The algorithm has demographics and the algorithm cannot see demographics. What happens? Well, the identified algorithm, which means the unblinded algorithm, reports lower default but selects fewer women. And this, in a way, coming back to my initial point, if demographics provide an independent signal of creditworthiness, then of course an algorithm will train on them. And especially in a context such as Pakistan, where your gender comes from your ID card, which they had to submit when they applied for a loan, everything else was self-reported, right? So that is one of the cleanest variables that you can have is your gender in this type of context. And so if that provides a signal of repayment, because of whatever underlying structural reasons that may be, an algorithm will load on it. And we see that I hold overall approval constant, right, to have a fair kind of comparison between the blind and the unblinded algorithm. And the algorithm selects fewer women, and overall default, even though this is not very clear to see, is lower. And then I did this you can do this with multiple splits, right? Because unlike the humans, I can re-randomize on the algorithm side as many times as I want. Okay. So now you might say, okay, why do the loan officers approve more women when they view demographics? What's happening? 2 explanations. 1, loan officers use gender as a signal of creditworthiness. They actually believe that women are more likely to repay. Or 2, loan officers have an equity preference. They just want to promote more credit for women in this context. I find strong evidence in favor of the equity channel, and there are multiple ways I do this. The officers were asked to give me a probability of repayment for all the women in the sample. So in addition to saying yes or no, they actually had to say, what is the likelihood that a borrower will repay? If I control for this officer assigned, like my own assigned probability of repayment, even controlling for that, the loan officers approve more women, which indicates to me that the equity motive might be at play. Interestingly, the review time also falls for female applicants in the second treatment group, whereas it doesn't for males. So the time I take to review an application falls, which is consistent with the rule of thumb behavior, which I see a woman, then I'm less likely to look at other things. And then interestingly, the increase in female approval rates is uniform across officers. So there were 30 loan officers, right? So I can actually see what the shift was across all loan officers. And it's also consistent across applicant socioeconomic characteristics. So low education females are just as likely to receive this bump as high education females. And why does the algorithm really load on gender when it sees that variable? And one way you can test this, which I think is interesting, is instead of asking the algorithm to predict default, I ask the blind algorithm to predict minority status, which is to say, can you creatively just use the variables that you see to unblind the borrower, which in developed economy credit markets you can, right? So in a US context, people have find that if I see someone's zip code, if I see someone's credit score, if I see someone's income, I can pretty much make up their race. But here you see that the algorithm is not able to do this because obviously the observable data is self-reported and not rich enough. So the recall is the key variable here. It says of the true women in the sample, how many are classified by the algorithm as women, and only 44% of true women are classified as women. And for minority men, it's even worse. Okay, in the remaining time, I want to talk about discrimination. So I'll abstract from the math, but the definition of discrimination that I use is it's the difference in approval rates on average for otherwise equally creditworthy majority and minority group individuals. So that means if I am just as likely to default and I'm in the minority group as someone in the majority group, and there are differences in the approval decision, then that is discrimination, which aligns with definitions of discrimination in the machine learning, economics, legal literature, what have you. Now, normally you have to construct this because you don't know someone's true propensity to default. But again, these loans were previously submitted and approved, so I know whether they defaulted or not. So for me, it's actually as simple as doing a regression of approval on an indicator of whether you belong in the majority group and the true default outcome. Because then you're able to residualize anything that's approval linked that's linked to default, and then the eta 1 coefficient, which if positive leads to discrimination, would tell me that there's discrimination, according to this definition. And consistent with the results I showed you, providing identities to the officers and the algorithm has opposing effects on each agent's gender-based discrimination level. So here's that discrimination coefficient for women, and you can see that when they're both blind, they're both discriminating against women, but when they have demographics, the unblinded loan officer's discrimination goes down, and the identified algorithm's discrimination goes up. I'll skip this. Okay, so now let's think about what is the optimal choice in the minute that I have left. So suppose this is an indifference curve. Suppose this is a budget constraint, where on the y-axis is the repayment rate for approved loans, on the x-axis is the discrimination parameter, right? So you're trading off equity and efficiency. And so what you see is that the the identified algorithm that sees everything achieves a higher repayment rate, as you might expect, but discriminates more, right? And then when it's blinded, it goes along the budget constraint. In a way, the loan officers, if you might think, machine learning algorithms are trained to be efficient, right? So the loan officers are almost like within the budget constraint. So it's feasible for them to move northeast in a way that it's not for the machine. And now think of this not as a budget constraint, but as an indifference curve. So now efficiency and equity are perfect substitutes. It's a very stylized case, but the data is real, but just me thinking that they're perfect substitutes is stylized. So now what I do is I restrict the algorithm to approve the same fraction of women and Baloch and Khyber Pakhtunkhwa men as the humans did when they saw those, because I think the humans don't discriminate based on my definition, so that's the appropriate fraction of people you should approve. And then let the algorithm run wild and pick as many of those people as it wants. Whichever of those people as it wants. And then we find in that situation, the identified algorithm is is still lower. Obviously, there's a little bit of a loss in efficiency, but there's a bigger gain in equity, and that the discrimination parameter is now close to 0. Okay, so I'll skip the conclusion, but let me talk about the policy implications for a second. I think there's been a huge cultural phenomenon that, oh, microfinance is a female-centric product. It's supposed to create female empowerment. It's true in Pakistan. It's true around the developing world. And I think this is the first test that says that these institutional preferences for gender equity and financial access actually appear to trickle down to the loan officers, right? I had 30 loan officers, 28 of them were men, and uniformly, when they see that someone's a woman, they're approving more women. And also regulations that prohibit algorithms from viewing demographics. I talked to the Pakistan Microfinance Network. In Pakistan, there are no regulations. A fintech company can take everything that it wants from your cell phone and obviously ask for your ID card, which means it can observe your age and your gender and so on. Regulations that prohibit algorithms from viewing demographics or discipline algorithms using the credit agent's preferences or the microfinance bank's preferences or any particular agent's preferences may improve efficiency while ensuring equity in developing economy financial markets. Because if not, then there is a concern that the use of machine learning algorithms undisciplined would just exacerbate the digital divide, which I believe is happening. So that's all on my side. Sorry if I ran long. Thanks.
Thank you so much, Faizaan, and I had a great time reading your paper, so thank you for the presentation as well. I think the paper is really well done. It's very polished. The results are very clearly explained. I'll just spend maybe half a minute talking about the key takeaways. So the paper is studying this sort of trade-off between sort of equity and efficiency, when you use machines or algorithms versus humans in making credit allocation decisions. So they're testing 4 conditions. When you have a blind loan officer who cannot observe demographics, you have a blind algorithm, same kind of situation, identified loan officer who can observe demographics, and an identified algorithm that can observe demographics. And they're looking at outcomes such as approval rates of loans, default rates, and discrimination levels for women. So the key results are as follows. So the blind algorithm is essentially the most efficient one. It achieves 21% lower default. And this algorithmic efficiency, the magnitude of this is quite large. If you compare this to, let's say, versus what you find in developed country markets. So this is an effect of 30 to 45% versus an effect of 5 to 10% in developed country markets. And then when you use the identified loan officer treatment, you find that approval rates for women improve substantially. So there seems to be a strong equity motive underlying the loan officer's decision. And while the identified algorithm does not exhibit similar levels of discrimination towards women relative to the blind algorithm. So the paper really kind of highlights, the trade-off between equity and efficiency and the importance of carefully managing that trade-off when we're considering digital lending. Okay. So my main comment on the paper is to just to kind of strengthen the discussion on external validity. While I feel the internal validity is really well addressed because this is a really clean experiment, you have a lot of control over how the sample of loans is created and the treatments that you're testing. But I do encourage you to sort of think of external validity, and in particular, the human treatment where you have loan officers, you're using loan officers from a microfinance bank. And one wonders whether loan officers from microfinance banks have sort of more equity preference towards women than an average loan officer, which you might find in a non-microfinance bank. So that's one key comment. Of course, you cannot go back and redo the experiment. It would be interesting to sort of reflect on this point a bit, and then to think a bit more about to what extent results might also generalize if you had different loan samples, right? If you're really sort of looking at very small loans, this is important kind of loan for consumption smoothing, but there are other types of loans, larger loans or loans for business purposes, and a discussion just around that would be helpful. And one way in which you can sort of approach this is to sort of look at prior work. It could be from a developed or a developing country context, and see to what extent you see this sort of efficiency equity trade-off in those other contexts, right? And that might help you sort of shed more light on external validity. Now, one of the sort of key channels which we are observing here is this equity motive that loan officers seem to have for women. And the other channel which the paper highlights is sort of the repayment channel, right? So do loan officers perceive women to be more credit worthy, and that's why they're sort of approving more women, or is it that they just have a gender preference for approving loans for women? To me, it's really hard to disentangle the two, because these repayment probabilities, as you even show in sort of looking at how the loan officers behave with respect to sort of approving loans, these are assigned by the loan officers, right? Even though they're looking at the characteristics, but there's still sort of a decision which the loan officer has to make while assigning the the repayment probability on the basis of which then they approve the loans. And that might reflect the equity preference itself. So to me, this is a bit hard to disentangle, and I just wonder if the paper can acknowledge that or sort of discuss that a bit more. One way that you could try to get to it empirically is to kind of see what happens to the repayment probability distribution for females versus males in the blind loan officer versus the identified loan officer group, and does it shift, which might then reflect that that we are actually seeing a shifting of how they perceive the creditworthiness of the borrowers. Finally, another sort of, I guess, direct test of equity motive could be that, since you have this rule which the loan officers follow in terms of approving loans, you could just observe whether the probability of being female is going to increase discontinuously at this threshold repayment, right? And that might sort of be even more evidence, even though you have quite a lot of evidence for the equity motive, but that could be sort of like this direct evidence that, at the threshold, you kind of observing something happening, which is that, these loan officers seem to prefer approving females. Which you should not observe for the algorithm, by the way, and that should sort of, so the probability of being female at whatever threshold, the algorithm is using to approve loans should actually just be smooth, right? All right, so one other thing, while the paper sort of really does a great job discussing women, I do feel that there's a bit of a gap with respect to the minority men results. In particular, in one of your pictures, I think the second test, you show that the identified algorithm relative to the blind algorithm actually is approving fewer women, but is also approving more minority men. So what's going on there? I'm a bit confused about that, and especially if you look at the second graph, I don't have these up here, but we could go back to the slides. These approved minority men have higher default rates, and this to me is a bit puzzling, because I would imagine the algorithm is trying to minimize default, right? So I think a bit more discussion around this, what happens to minority men, because we're focused on the discrimination or equity preference for women, but what about this second group, which you've also sort of tried to sort of represent well in your sample? I think discussion around that would be really helpful. And my final comment, and I think you've already incorporated this, which is to kind of do this with sort of, the algorithm actually incorporating the equity preference. And you've shown this, so I won't dwell on this too much. But I really think that, so the paper is really well done. It speaks to this important sort of issue about equity and efficiency trade-off. One other sort of direction in which you could take the policy implication is to also think of, when, if as you show in, when you incorporate the equity preference, that algorithm, the identified algorithm does very well, right? So, if you have a world in which these kind of algorithms where you impose equity preferences on them are going to replace humans, what would that do to, this sort of like this substitution between, humans and machines, what would that do to labor markets and the way that these financial markets work as well? So that's another direction. Of course, the paper is not about that, but I guess, future discussion, future work on that. So I'll stop here, and I think we'll have about 10 minutes for discussion or questions from the audience. And if you have a question, please raise your hand. The mic will come around to you.
Thank you, Faizaan. This is super interesting. And by the way, I've taught this in class and students love it. But I had a question on the the default and how are there particular characteristics that the algorithm is able to pick that the loan officers aren't? Are they concentrating too much on the gender to not know what's actually reducing default? And the other thing is I'm wondering if in the context, because this is also a time when there was a moratorium because of COVID on consumer repayments, is your sample impacted by it? Was this I don't know if the MFI had something which was requiring them to give that moratorium, in which case, it's gender becomes more important, not necessarily whether they're going to pay back the loan on time.
Hi, Asad. One question. So I think this is related to what Ayesha is also asking is like, what is the information that the algorithm has? So one is like what you're providing, but loan officers have been working in this space for a very long time. So maybe there is some historic information or like their own training and experience that is not incorporated within the treatment that you have. So if you were to provide that extra information or more data to the algorithm, would it change the results or not?
Hello? Yeah. Okay, thank you. Let me quickly take some time to respond. So I think on your external validity point, I think the way there are two ways that I would pitch this as an external validity point. The first one is, in my opinion, even if we limit just to the microfinance world, in my opinion, I think that is such a big market around the developing world that if that is the extent of the external validity, I'm perfectly happy with that, given how huge of a market it is, how extensively it's been studied. But this particular feature has not really received any attention. So maybe that's kind of a limiting thing, but in my opinion, it's not. But I would say the second thing that makes it even more broad is in any type of credit market context, which I think is broader, there's no perfectly equal societies. There'll always be a majority group and a minority groups. And because of structural reasons in the data, those minority groups will always could have worse outcomes on certain characteristics. And what I show is that in that type of setting, if you're exclusively relying on a machine, then the machine will load on that variable. And in the presence of poor data, it will load on that variable and it won't be able to reconstruct that using the data that it sees if it's blinded. And I think that kind of result, I would say, transcends credit markets. As long as there's not perfect equality, which I don't think there ever is, right? So on the repayment point, on the equity motive, I would say the repayment probability does shift. I showed that in the paper. So yes, loan officers do assign a higher repayment probability to women, but that could also be because they are trying to be internally consistent with their equity rule, right? And so loan officers could say, I have to give this woman a higher probability of repayment. Otherwise, I won't be considered a good loan officer. And as you alluded to in the paper, I didn't have time to show, the loan officers follow a very discrete threshold rule. So they assign a probability of repayment, and it's different for every loan officer, but above X, so for a loan officer, above 60% probability, if I assign a person to have more than 60% probability of repayment, for everyone higher than that, I approve a loan. And everyone below that, I don't approve a loan. So the loan officers are taking this seriously, and they're following kind of a consistent threshold rule. But I like your suggestion on the probability of being female around the threshold. I think that and the machine shouldn't. I agree. So yeah, that's and it's feasible to do as well. So yeah. On default and what is happening, I think the first point is just a clarifying. The loans had already been disbursed in 2019 before COVID. So COVID really didn't have a role to play. The loan officers were told that these are real loans and that they had been submitted over the past, so many years. And at that time, the microfinance bank did not have any moratoria on defaults. So that's on that. On what is happening, one thing that I don't remember is I did variable importance plots for the machine. So a machine learning algorithm, you can see which variable does the machine give the most importance to. I don't know what variables the humans give the most importance to. The one thing I haven't done, just because of time reasons on my end, is I asked the loan officers to provide written comments in addition to their approval decision. Like, why did you approve? Why did you not approve? And so I could transcribe those, code them up, and then actually give you a sense of how they compare. That's been on the list for ages. I just need to get to it. So I think I don't know if I missed anything, but yeah.
So there's one question over there.
Interesting paper. My question is, let's assume that all the microfinance banks are profit maximizers, right? So what incentives do they have to use? bec- Because if I'm not wrong, your blind algorithm is 21% more efficient than the loan officer, right? So what incentives do they have to use loan officers instead of blind algorithm? Eventually, when you transition to digital economy, so I'm assuming you tend to go more towards algorithms and automate the entire process, right? So how do you, policy-wise, how do you make sure that this discrimination doesn't occur when there's a shift in the digital?
So I did think about this. I have a slightly more optimistic take, because one thing that I did not get into, so the question for future research, is how valuable is the soft information that the humans can see? Because loan officers go into someone's home, they'll kind of evaluate their situation. Similarly, machines can also see soft information because they can scrape your cell phone, so they might see what time you set your alarm, what time, how many people you call, and I did not get that data for this experiment. So I think my sense from a policy perspective, having looked at related literature, is I actually think that this is a situation where a combination can be really helpful. Loan officers, if you work with microfinance banks, have to spend many hours in a day to go and screen applicants and to go and evaluate credit outcomes. What I've heard from microfinance banks in Pakistan is that loan officers are becoming more efficient if they have a machine evaluate and provide a credit score, and for the credit scores that are below X provided by the machine, then they'll go in and target those borrowers for more enhanced screening. And so I think that in reality, as the demand for credit increases, it's infeasible to expect humans to do the type of screening that they do. The demand for the loan amount increases as well as the number of borrowers. And I think some combination might be the best solution in that situation.
Great. So the next presentation is mine, and I'll just step up. Okay, so this is the final presentation of the session, and I will be talking about my work on addressing deepfake misinformation through educational interventions. This is joint work with colleagues at Computer Science Department here at LUMS, Aghali Raza and Ahsan Ayub Qazi. So the motivation for our work really is that while rapid advances in digital technologies have been bringing many benefits for developing economies especially, there are concerns about negative externalities. And misinformation, what we typically refer to as fake news, is one such externality that societies have to grapple with increasingly. And prior work shows that misinformation can have lots of adverse consequences. It can polarize discourse. It affects people's beliefs. It threatens electoral integrity, and it is really persuasive. While misinformation comes in many shades and forms, one of the sort of rising forms of misinformation is deepfakes, which, as you may be aware, are technologies which allow the voice and facial expressions, or essentially a video of anyone, to be sort of reproduced with a lot of accuracy. And this creates a lot of complexity for the average person who's just sort of trying to navigate the information realm in the digital space. Here are some examples of recent deepfake misinformation. So this one example where deepfakes were being used to sort of manipulate people's beliefs around election times in Pakistan. And here's another one, where deepfakes were being used to essentially target female politicians. Now, in developing countries, the problem of misinformation or deepfakes also intersects with another crucial challenge, which is lack of digital literacy. Digital literacy is not just about what skills people have. It is also about how good they are at evaluating information which they encounter online. So for example, someone might be able to use Google search, but when they get their search results, are they able to sift through and realize what's sponsored, what's authentic, what's organic, and et cetera, right? So while we know that gaps in basic digital skills are really wide, gaps in information evaluation skills are really unmeasured across countries. One way in which we can counter misinformation is to focus on individuals or people who consume information online and think about how to raise their competencies and make them more resilient to misinformation. And this approach is what we call the demand-side approach to countering misinformation. And the demand-side approach essentially sort of, the three main types of interventions which have been tried to essentially build more resilience against misinformation. These are nudges, which would be just simply sort of like, prompts or accuracy reminders to tell people about paying attention to accuracy when they're consuming news. Boosts or educational interventions, which are designed to sort of, build more sort of foundational competencies. For example, media literacy programs or inoculation strategies, which sort of borrow from the medical literature. Essentially, it's a way of teaching people about something new by exposing them to some weakened form of misinformation and trying to sort of build resilience by giving them sort of more experience with those types of content. And finally, refutation, which is sort of after someone is exposed to or sees a news, you could have, for example, a fact-checking label or a debunking claim attached to that, and these are the three main types of demand-side approaches. And while there's a lot of evidence which comes from developed countries about how these approaches work, and they're generally effective with sort of mixed results, but there's a lot of gap in terms of how these approaches work in low and middle income countries. Some of these gaps would be, for example, looking at how these approaches would work with people who have low levels of digital literacy or low levels of education, and also with misinformation which comes in more complex forms, for example, audio deepfakes, where you don't have a lot of visual sort of clues or context, all you hear is a voice, right? And then, there's also sort of a gap in terms of understanding, how these interventions perform if they're scaled up, or, what are the long-term effects. In our paper, we try to address some of these gaps. In particular, we are sort of really focused on looking at samples which are inclusive of low digital literacy populations, okay? And we are also focused on looking at these sophisticated forms of misinformation, particularly audio deepfakes. And our study, just to give you context, is taking place in the months just prior to the 2024 election this year, where social media was being intensively used to both obtain and disseminate political information. And in this paper, we exclusively focus on political news and political misinformation. And finally, we evaluate a range of interventions. So we, the few different kind of options of interventions that I showed you, we're testing out all of the main kinds. So research questions that I'm going to talk about today. So firstly, do demand-side interventions work in improving accuracy of beliefs about political news and particularly deepfakes, and also discernment, right? How good people are at discerning between truth versus falsehood. And is the effectiveness of these interventions impacted by characteristics of individuals, for example, digital literacy, because that is sort of our motivating kind of theme here. Okay, so here's a snapshot of the sample we have. We have about 2,900 social media users. We've recruited them through a field survey. This was done in Lahore. We focus specifically on areas within Lahore, where we find a lot of support or sort of comparable support for the two biggest parties in the country right now. So that's what we use, and we use the sort of 2018 election data to help us identify those places within the city. Half of our sample is female. We're really kind of looking at the lower sort of middle income groups here. Median age is 29 years. Median education is grade 10. There's a lot of smartphone ownership. We also capture digital literacy. This is one of the innovations of our paper. We not only use survey-based measures, but we also get them to do some simple tasks for us, and that gives us a more objective measure of digital literacy. Digital literacy is going to be a score which we're going to capture between 0 and 1, so the median here is 0.52. In terms of what social media platforms people use, the most common is, of course, WhatsApp, followed closely by YouTube, and then the rest are here. Okay, so what are the interventions that we're going to test out? We try 4 different interventions. The first one is the simplest one, where we just give an accuracy nudge. And all of these interventions are delivered via videos. So we get people to watch a short video which contains these different types of interventions. So in the accuracy nudge, we just tell people to think about accuracy when they're reading news without really kind of telling them about how to identify or think about fake news, how to discern it from true news. In the tips intervention, we tell them about common ways that they could sort of recognize fake news content. online, both for sort of textual or image-based misinformation as well as for deepfakes. And thirdly, we have a video about psychological inoculation where we tell individuals about the common techniques which fake news creators use to sort of spread and create and spread fake news. And finally, we have the last intervention, which is focused on teaching people about using fact-checking. So this is, we use one of the sort of common fact-checking services, Soch Fact Check, which is in Urdu language. And we tell people about how to use that service. Okay, so here's a map of how we proceed. So this is a two-stage RCT. We have the first experiment, which we call stage 1, where we're just testing the most basic treatment, which is an accuracy nudge. So we label that as T1. We have a control group. The control group watches a placebo video. By the time stage 1 ends, or at the end of stage 1, the control group also sees the accuracy nudge video, before stage 1 ends. So this is, one experiment. The second experiment is that we come back and we then get them to view more complex media literacy interventions or media literacy videos. So this is your T2, T3, and T4, tips, inoculation, navigating a fact-checking service. Here's a timeline of events. The first visit, you have your baseline survey, the first experiment, and then we measure the effectiveness of the accuracy nudge using experimental stimuli. These are basically news stories, and I'll show you some examples of those. Then we have visit 2, where we do the second experiment, and then this is followed by more stimuli for evaluation, and then we return to these respondents 4 weeks after visit 2. Okay. So we look at, so the experimental stimuli consist of both screenshots, which have sort of textual or image-based news, as well as what we call video with static images. So these are essentially audios. We don't have any sort of live video or sort of moving video in any of our in our stimuli. And this is one of the sort of common ways in which people are consuming news, especially those who are less literate or less sort of read less, but they're sort of more in the oral tradition. So while this is common also on video watching platforms like YouTube, but also on your sort of standard like WhatsApp, etc., you see a lot of these kind of news stories being forwarded, which are just essentially audios with static images. The key question we ask for each stimulus is the claim in the news clip accurate, right? So we ask people whether they think, what the news story is saying is true or not. So that's what, they need to sort of tell us. And the answer is binary, yes or no, and that's what sort of helps us identify accuracy of beliefs. Okay. We also stratify the stimuli in terms of sort of false and true. So we have a mix of false and true stimuli, right? So some are fake news, some are real news. We also stratify by political stance. And within each cell, we also stratify by the format of the news. So we've got some screenshots, we've got some real audios, and then we've got some synthetically generated audios. And we have, so we have both synthetically generated false audios, so these would be your deepfakes, and then we have your synthetically generated true audios, where the claim is true, but we generated it using a machine. Okay. So here's the picture summarizing the treatment effects. We're looking at 2 outcomes, accuracy and discernment. Accuracy is the proportion of correctly identified news items for each respondent, and discernment is the difference between true positives minus false positives. Okay, so we segregate by all news, so the black lines are for all news, false news and true discernment is an overall metric. Now you see all treatments move accuracy and discernment in the positive direction, but the only statistically significant effect is for T4. That's your fact-checking video. The other sort of pattern you see is that every treatment shifts fake news or false news accuracy more, right? So people are really sort of learning something, especially if you look at the tips video, right? Or even the fact-checking video. While the accuracy of true news is not affected. In fact, doesn't move in the negative direction, which is good because we don't see people just labeling news as fake because they've just been primed to think of misinformation or fake news. Here are the treatment effects in a table, and as I said, the simplest treatment has no statistically significant effects. The tips video improves accuracy for fake news, does not change accuracy of true news at all. The inoculation video has no statistically significant effects. The fact-checking video, interestingly, has the largest effects. So it improves overall accuracy, it improves the accuracy of false news, and it also improves truth discernment, right? How good you are between discerning between true versus fake news. If you look at synthetic audios only, remember these are what we were sort of thinking about as the more sophisticated forms of misinformation. So this column would be your deepfakes, right? You find more pronounced effects. You find an effect also of the accuracy nudge video, and nothing for the inoculation video, but again the same pattern for the tips video, and similarly for the fact-checking video. Both these treatments are improving accuracy, and these effects are more pronounced for synthetic news types. Okay. I'm just going to briefly talk about other outcomes we look at. We look at whether they, so we ask them after every stimulus, do they intend to share it? Would you like to share this news, right? So we don't find much of an effect on sharing intentions for any of the treatments, accuracy nudge, fact-checking, or tips. For inoculation, interestingly, we find large effects. These are actually large effects on sharing for both true and false news, but no improvement in sharing discernment, which again is a metric which we construct to look at how good they are between discerning true versus fake news, and while they give us their sharing intentions. We also don't find much of an effect on emotional responses, right? So we ask them also after every new stimulus, how did you feel? And our key outcome is looking at whether they reported non-neutral emotions, so we don't find much of an effect on that. Okay, so we look at heterogeneous treatment effects, and this is one of the sort of things that we were really interested in looking at, the intersection between sort of how good you are at identifying fake news, or what are your accuracy of beliefs, and your digital literacy. So if we segregate between high and low digital literacy of subsamples, we find that those with higher digital literacy do tend to sort of benefit more from every treatment. So when we look at this, this is really significant, and it's significantly different than those who have lower levels of digital literacy. We don't find much difference in terms of other characteristics. So we look at what's called a cognitive reflection score, which is essentially how much you reason versus how, to what extent you give intuitive answers. We also look at whether your level of political knowledge, high versus low, male versus females, age or education. Interestingly, for education, we find sort of some opposite effects. So those with sort of lower levels of education tend to kind of benefit more from the fact-checking video, of course, conditional on digital literacy levels. Okay, so key findings, the fact-checking video was the most successful. It improved truth discernment. It increased overall accuracy of beliefs. And these effects are more pronounced for synthetic audios or your deepfakes as well. And similarly for tips video, it enhanced accuracy, and especially for false news. No effects of inoculation video. The accuracy nudge video does not overall improve accuracy judgments. And individuals with high digital literacy scores benefit more. So mechanisms, we're doing more work to explore this, but our preliminary sort of understanding of what the data is showing to us, we asked this question after every stimulus: why do you think a news story is true or false? And we are right now doing a textual analysis of the participant responses. And one of the findings which is emerging is that people in T4 are more likely to mention factual reasons, less likely to have emotional reactions, and less likely to mention prior beliefs. And that leads us to think that this video is actually shifting attention from emotional or intuitive evaluation to factual evaluation. Okay. For the tips video, we think that because the focus is on tips to identify fake news, and this is what respondents are really looking out for. The good thing is that in this video, we also sort of talk about true news, so it's not sort of doing the unintended consequence, which is making people more skeptical or just kind of reducing accuracy of true news, but it's definitely improving the accuracy of fake news more. For inoculation video, we just think that it created more caution about spreading any information without improving accuracy. Okay, so implications and conclusions. So key takeaways so far. we have tried 4 different demand-side interventions, and we find that these interventions show promise in improving belief accuracy about political misinformation as well as deepfakes. Different interventions have different effects. Fact-checking or teaching people how to use fact-checking improves accuracy and discernment, while inoculation reduces sharing. These findings can have policy implications for developing countries trying to design digital literacy or media literacy programs, or for platforms thinking about misinformation regulation policies. But we also need to do more work, and especially sort of thinking of the future of this agenda, this research agenda. What is the best way to combine interventions or to sort of create more lasting impact? That's the next item that we'd like to sort of pursue in future work. So I'll just end here and.
Great. So I really enjoyed learning about this work. I think this is fascinating. So thanks for the opportunity. Let me start off by summarizing what I understood this paper is doing. Essentially, they are asking this question that in this scenario where there's a lot of political misinformation, how can these demand-side interventions, where you're targeting the consumer of the information, to detect false information, to identify whether something is fake or real, right? So that's their goal. And they're also considering whether these interventions have different effects depending on characteristics of the participant, right? So if you are more digitally literate, are these interventions more effective on you versus if in our context where digital literacy is sort of limited, what are the limitations on the interventions? Just to quickly summarize, they ran an experiment with about 3,000 participants from Lahore. And in the first stage, they are given information on, just nudged on information on accuracy. So just telling people that, hey, think about the accuracy of that information. Like that's just all they tell them. In the second stage, they cross-randomize all their participants into 4 treatments. And as Ayesha very well explained, in the TIPS treatment, they are informed and they're told to sort of think of ways to verify information. Then there is psychological inoculation, fact-checking, and then there's, of course, that treatment group. Participants' accuracy perceptions are recorded after each stage. So they're treated, and then they give information on the stimuli, so all those screenshots and audios that they listen to, then they are reporting on that. Just a summary of the finding is that there is limited or no impact of the accuracy nudges, which sort of aligns with the literature that low-key nudges or small interventions have small effects or no effects in many contexts. So this sort of works with that. They find that the fact-checking video is the one which has the most sort of impact on truth discernment and overall accuracy. TIPS treatment sort of enhance their accuracy for identifying false news. And finally, the digital literacy matters, right? So these interventions are more effective when people are digitally literate than if they're not. So I think there are a lot of good things about this paper. This is very timely and relevant paper. We have this political polarization in the country, which is worsening, and misinformation is at play. You see it all around us. I think Farah, in her slides, highlights some of the cases which really makes the point of how this fake information or false information is impacting societal outcomes, not just electoral outcomes, but overall society is being affected because of false information. So thinking about how we can address that is a really important issue. They have a very clean design. It's a very simple 2-stage design where they, and the sample size is large, so about 3,000 participants. So per treatment, they have about 8 to 900 participants, so that's sort of good. And the interventions are well thought out. They're related to the literature, so they're very practical. I think they sort of find some policy relevant insights. And they, by running this experiment, they're able to identify some interventions which have the potential to be scaled up. And it will be interesting to see how they sort of do if they expand on those interventions. Now, I had few questions about the experiment design, and this is probably because I'm looking at the slides, and maybe for when you write the full paper, you'll have more details on them. But I was wondering more about the details of the contents, like what exactly was in the videos. So you gave us sort of a broad outline of what was mentioned, but I think it will be interesting to see what exactly were the contents of those videos. I was also wondering how long were these videos, right? So what should I expect from the perspective of how participants engage with these videos? Are they going to watch all of them? Are they going to skip them? So that's something I think can provide more clarity. You did mention that you recruited these participants on the areas which were politically sort of not polarized or not in one direction. So there were sort of the electoral margin there was 20% gap in the electoral victory from the last election. But I was wondering how the participants were actually recruited, as in just thinking at the very micro, at a very logistical level, that are you sitting with them? Are they watching video while your subjects are monitoring them, or do you make them watch those videos? I understand that this is done in person, so this is not like they're sitting in their homes and somebody's watching videos on YouTube or playing something on WhatsApp, which is typically how we receive information. So I think this is something which seem a bit unnatural, at least from what I understood how you're treating them. But you can clarify us what exactly how this information was delivered. And you do have these three different stimuli where you are using screenshots and these audios, synthetic and real. But I did not see any analysis of the differences in these responses. So are people able to detect truth more for the screenshots versus the audios? I would imagine that the audios are probably harder because screenshots do a really good job at faking audios. But I could be wrong, like could be in any direction. So I think it would be interesting to see how your effects vary by the type of stimuli. Uh, on the fact-checking videos, I think that's because that's where you have the strongest effects. I was wondering what is the mechanism of that? Are people actually using those services more now? So once they are informed to check or verify the source of the information, and you just mentioned in your presentation that you use this Soch fact-checking service. So do you see participants actually going to that service to verify the information? How easy it is to go and verify? And would that translate into a more natural setting where they see information and would they go and check that? I am concerned. I think it's again because of the fact that this is done in person, and my understanding is that these subjects understand or they know that they're part of the experiment or the part of the study. So that always has this typical concern of are they responding as if they would respond in a natural setting? And my concern comes from the fact that in a field setting or in a natural setting, uh, people generally consume information or misinformation without thinking too much about this. But in your setting, you're asking them to think about this, and that is a different cognitive load that they're engaging, which might not be what they would do if they encountered misinformation elsewhere. So maybe from that aspect, what the effects that you're finding are the sort of the upper bound of what if you really make people think about this, then that's what we can do. So would love to hear more thoughts on that. So I was also thinking that if you have other outcomes other than this, what they're doing on the stimuli or how they're answering to your question about the stimuli, if you know anything about their behavior on like what kind of news do they sort of now start using more? Do they subscribe to channels which are more authenticated now? So is there anything other than what you show them in the experiment that you can sort of bring in and look at to see how these effects sort of translate? I think that will take care of the demand effects where you can see that, okay, this is not just in these, but it sort of reflects in other outcomes. One thing that I was hoping, or not really hoping, but I was expecting you to show in the heterogeneity is how these effects vary by their political affiliation, right? So you have pro-PTI and pro-PMLN news, and I'm guessing you will have some information about their political affiliation, which party they voted for in the last election, or something like that. And so there's a lot of literature on this confirmation bias, right? So I've cited this paper by Robin and Schrack, where they have this model of people tend to reinforce their beliefs. So if I have positive priors about PTI, and if you give me positive information, I'll tend to believe more on that. But if you give me some counter argument or counter information, I'll just not update my beliefs in a Bayesian manner. So I'm thinking that if you have information on political affiliation, how do you see any evidence of confirmation bias, and do your treatments have different impact on sort of reducing the confirmation bias, right? So that's one thing. There are some other comments here. I think MHT, this is a standard thing. Yeah, I think you need to think about multiple hypothesis testing. You have multiple outcomes, multiple treatments. I think this is something you should test, whether these effects that you're finding are robust to those adjustments. I think my sense is that what the effects that you are reporting are from the activity that they did right after getting the treatment. But do these effects last after, like, in your 4-month follow-up, when you follow them after 4 weeks or whatever follow-up that you're doing? Do these effects survive then? I think it might be interesting to see the interaction, because you have a two-stage design, so you can see the interaction of accuracy nudges with other nudges. Are they reinforcing them? On net, on average, you're finding that the accuracy nudge has sort of very limited impact, but maybe in combination with other nudges, they sort of work better, and that can tell us what might be the optimal sort of sequence of nudges. Yeah, I think this is standard. The effect sizes could be related to the literature. I do think, and I don't know where you're going with this work as a future agenda, but I do think that linking these two, or thinking about scaling up, because you have work with Facebook, right? So you have this engagement with them. So thinking about actually integrating some of these into real Facebook interventions, and looking at how people engage with content at that level. And so that can tell us more about what happens when you scale these interventions at a wider scale. And finally, I think thinking about real-world outcomes eventually, that reducing misinformation, because eventually what we care about is we want to reduce political polarization, we want to correct people's beliefs. So how do these lab-based interventions translate into sort of real outcomes? But yeah, I think this is exciting work. I really enjoyed learning about this, and I think this has a lot of potential. Thank you.
Take some questions from the audience before I'll just collect them, and then I'll share my reactions. Yes, please.
Thank you so much. It was very informative. I just have, adding to your last comment that you have mentioned, that you have mentioned the fact checking services. So I'm really concerned about that if two people who are belonging to two different parties and they are going to a fact checking service, wouldn't it be a different opinion from both of the sides, that whether, for example, I'll just mention an example, if I'm following PTI and the fact service is asking me that this information is wrong, then I would say it is not wrong, it is right. So the accuracy of the fact checking service really matters a lot, and what are the parameters that will define the accuracy of those services? Thank you.
Other questions?
So just a question on clarification, Ayesha. So all the content that these subjects were exposed to, is it all have to do with politicians and political opinions? I see, okay. So then my question is, I mean, so what was the choice in that? Because it seems like then your results are only then limited to people's political opinions or political beliefs, right? To what extent does this extend to, or to what extent do you think the results of, say, the efficacy of fact-checking services might extend to opinions about things that people might not care so much about, for example, you know, about the population of blue whales, for example, or something of that sort. I hope you see what I'm getting at. Thanks.
Right, so that's on external validity. Okay, other questions? Yes.
I haven't fully thought this through, but I wondered if you had any theoretical reasonings to expect that belief in false information has different mechanisms than disbelief in true information. Because it's interesting to me that the treatments worked on partly on false information, but didn't work on disbelief in true information. And it's also interesting that you said that you were glad they didn't work negatively. So I wonder if there's, like, we might expect actually that if we keep using these types of interventions, that they might have people double guessing true information as well, and whether we would expect there to be different interventions would work better for that.
Okay. So I think I'll start by addressing first of all Sher Afghan's comments. So on the sort of delivery of interventions, so these videos were less than 2 minutes, and that could be sort of short or long depending on who watches it. And we spent a lot of time designing the content of the videos. We tried to sort of make it contextually relevant. It was in Urdu or sort of like easy Urdu, not very difficult words. And uh, uh, if you're interested, we can see the videos later. Sure. I think they're really sort of. I enjoyed creating them and working on them, and I think the LUMS Advancement Office had actually sort of later on converted them into sort of short sort of videos and put them somewhere. I don't know where, but so these are sort of the ways that we deliver the videos. In terms of the rollout, we focused on National Assembly constituencies, which using the 28 election results, where we found sort of similar levels of support for both of the large parties. So we tried to sort of keep that political balance, because we were really interested in sort of this political angle and political beliefs. And a paper, the results that I mentioned today are just kind of scratching the surface. And as you mentioned, there's a lot of other sort of directions we can take this analysis into. So the key sort of criteria for inclusion, when we go to the field, is that the participant has to be 18 years and above. We stratified on gender, so we did want that balance. The other inclusion criteria is that the participant has to have one social media application, or be using one social media application. Could be WhatsApp, TikTok, YouTube, whatever, right? So that was the inclusion criteria. In terms of how the interventions are done, which is in person, while we sort of have this understanding that, of course, that can create Hawthorne effects, etc., and we have to do more work to kind of address concern. One of the ways this translates naturally into a scaled version of these interventions is actually through educational programs. What we showed you are one-shot sort of interventions, where you watch a video for once. But there's a lot of interest in the policy community around countering misinformation, on designing sort of longer educational programs where you have a sequence of sort of training, let's say material, videos, or whatever, right? And people could do that in person, or of course they could do it on their own time. So that's kind of the setting where we think these kind of interventions would be scaled up and tried out in a natural sort of way. So we are looking at sort of the heterogeneity by stimuli, how effective it was for, let's say, synthetic, which is deepfake, plus the real synthetic, right, versus screenshots. And what I showed you was just the effects for the synthetic audios, and these are really pronounced. So these are more pronounced than if you just look at, what the effects for let's say, screenshots or just the real audios, okay? But I didn't show those today. Okay, and I just want to talk a bit about the longevity. So the results we showed you are the sort of pooled results for both the visits which happen after stage 2. And I don't have the results here, but if you separate, you do find dissipation of effects. So after you visit them, after 1 month, you do find that the effects die down, right? We're combining both endlines to improve accuracy, sort of precision, not the accuracy metric, but precision. But that's a sort of the point that speaks to how these interventions would be scaled up in a natural setting, right? So a one-shot intervention has short-term effects. This is essentially what we're going to be getting to. And then sort of we need, more sustained programs with more reinforcement if we really hope or think that, these programs can bring about lasting effects. In terms of sort of behavioral measures, we did an incentive compatible game with them. I don't have the data here to show you today, but essentially we were trying to look at what's their demand for using a fact-checking service. So we did this simple sort of BDM game, and that's the data that we hope to now start analyzing to see whether the interventions really sort of increase the demand for fact-checking or more factual information. On the sort of point about whether we're able to track them, we tried really hard about this sort of trying to be able to follow them after the experiment. But there are a lot of sort of privacy concerns. So the way that we tried to do this was to sort of get them to subscribe to a WhatsApp service where they could receive WhatsApp notifications about Soch fact check news items, fact check news items. But we find that, at the time that we were in the field, this was a particularly sort of sensitive time around political news. It was really difficult to get people to talk about their political views also. And so we were really limited in what we could do. Few people agreed to use that service, and they used it for a very short time. Later they essentially just blocked the service, and we were no longer able to track them. So we were limited, and I think that's a limitation we'll have to work with. In terms of looking at what happens with these treatments to the extent of the confirmation bias, right? Do these treatments work if the news that you're exposed to is sort of pro the party that you sort of identify with, right? And this is an area that we need to sort of do more work. Our preliminary results show that yes, it works. We are running into problems with precision, right? But we find evidence that the treatments, if you just focus on the stimuli, which is pro your party, right? But it's false. We do find the treatments have effects, right? They improve your accuracy of beliefs. So yes, it works. And in terms of the question about fact-checking services, well, fact-checking services, the way that they work is that they're supposed to be independent. So they do not have a political affiliation. And this is what we explain to them first in the video before we tell them about using Soch Fact Check, which is a common fact-checking service. So of course, the comment that you had, would someone trust fact-checking, if the service is telling them that the news, which is, sort of pro their parties is fake, right? Would they trust it or not? And the comment which Sher had earlier was to sort of look at specifically those stimuli which are sort of, pro your party and see whether the treatments work for those. And what we're finding, preliminary evidence, and we need to work more on this, is that yes, they do work. And I think your point about, what are the mechanisms or sort of how people, think about false news or belief in false news versus sort of disbelief in true information. I think that's a question that, we need to sort of think more carefully about. But the point that I was trying to make was that, we don't want people to sort of be just less trusting of news overall, because there is a mechanism, online media, social media does provide a way to reach people very easily, right? Think of the COVID pandemic, right? So there are times when you really want to disseminate, accurate information fast. So we do want people not to lose trust in online news overall, right? Which is why I said that, the way we create the tips video is that, yes, we focus on telling people about how to identify fake news, but we also tell them, look, social media is used to, spread or disseminate true news as well. And, here are some sort of key markers of true news as well, which is just in contrast to the false news, okay? So, again, I think we can do better, and we can think sort of on a more theoretical front, what is really sort of the cognitive mechanism driving belief or disbelief in false or true news. And I think this is an exciting area of research. And I think I've answered all questions, unless, yes, please go ahead. Mike.
I think it's a very good research. Just on in terms of how fact checking is perceived and how it is done, you need a lot of information to conduct fact checking. And sadly, I think around the time that you conducted the research, there was a lot of internet shutdowns as well. So there was a lot of lack of information that was promoting misinformation and disinformation on social media platforms at the time. So is that something that was taken into account when we were, or when you were, talking about how people could tackle fake news on social media platforms and how they can fact check fake news on social media platforms? And my second question on the same trajectory is, are 2-minute videos enough to teach such soft skills to internet users?
Right. I think both great questions. So on the first one, this is one of the key challenges of scaling or even doing these interventions at small scale in developing countries. That the institutional context is really so different. So there's an environment of media censorship. People were really afraid of disclosing their views, etc. Right? And as you're saying, these internet shutdowns were happening, and they were happening, even prior to that. So in terms of internal validity, thinking about the effects, the effects on accuracy and discernment, that's not affected because the same kind of effects are there for control group as well, right? So, and that's the advantage of having the experimental design. The other question is that whether these treatments, the one-shot treatments, are sufficient. We find evidence that they work, let's say in the short to medium term, but their effects start dissipating. Right? When you come back after 4 weeks, the effects are weaker, right? And presumably, if we went today, the effects might just have disappeared, altogether. Right? So what we were trying to sort of get to in terms of the scaling agenda, which is sort of agenda for future work, is how do you design such interventions in a sort of programmatic way, where you're not just doing it in one shot, but rather as a sequence of sort of, educational interventions which are going to be more long-lasting. Okay, I think that's it. Thank you very much for attending, and thank you for the great questions.